highly accurate, and it's very much corresponding to the number of photons that are leaving the body of water, which could be related to the biomass and the amount of phytoplankton.
Dr. Nima Pahlavan is working with NASA and the U.S. Geological Survey to make sure Landsat users have consistent, accurate, and ready-to-use data about lakes and rivers. Water is difficult to study from space because only a fraction of the sunlight is reflected back to the satellite. But engineering improvements on Landsat 8 have leveled up its ability to measure the small signals from water bodies. After Landsat collects the data, it gets beamed down to the USGS Eros Center, where it is archived. The raw numbers pass through checkpoints to align the geography, correct for sun strength, and then compensate for the effects of the atmosphere.
So you essentially removing those atmospheric scattering and absorption.
Let's break down what NEMA means here. To measure the amount of cyanobacteria, you need to know how much light reflected off the surface. But some of that light gets scattered by molecules in the atmosphere on the way to the satellite, lessening the signal received. And sometimes light that never made it to the surface gets scattered into the satellite, adding a false signal. Like removing the haze from a photograph. Atmospheric corrections leave you with a quantitative measurement of exactly how much light left the water, known as aquatic reflectance.
You want to look at the actual physical measurements to derive physically meaningful products